Okay, we're live. Though we should check our audio stuff. All right, well, I heard my voice. Say something.
Something.
Say something.
Something.
Say something. Okay. I was playing the stream. Okay, cool.
Well, I am watching an ad.
Oh, that's fun.
Okay, now it's good.
Like I was saying, today will be a good stream. But you were talking about this, the issue that I was at last time, which was a segmentation fault. And I think it was a stupid thing. And then I ran into another issue. And then that was a stupid thing. It's always a stupid thing. But I'm pretty sure all of the last couple streams, I guess I've been working on things that are very difficult and kind of boring because it's, hard to get things working. I mean, early on when we were writing code and it was just our code, like that could moves pretty smoothly because, it's like our little world. But as soon as Linux was introduced, it's like now you have to deal with this other system and integrate with it, and it's just becomes harder. But I think for what I wanted to accomplish, it's all working, so we can kind of do some other stuff. But I was gonna, let's go to the screen. But there's some other stuff too, because I want to say it's downhill from here, but that's a negative thing, right? what's the like?
Oh, I know. Smooth sailing.
Smooth sailing. Okay, it's all smooth sailing from here. Because that was the last like hard thing that I wanted to do for this release. There are like two other big things that are hard, but they almost work enough that I can make an issue and we'll figure them out. But like as a system as a whole, it's like all come together. And so because of that, I've been cleaning it up and getting it ready for release. And kind of maybe a milestone, I guess, is, we're working in the 0.3 branch. It's now merged back into main. So,
Nice.
It's, still kind of a work in progress, but Tom BH gave me a shout out to 9 viewers. I have no idea what that means, but I just saw that in my activity feed for this Twitch stream.
Thanks, Tom.
Gave me a shout out to 9 viewers. What 9 viewers? We don't have 9 viewers right now. Maybe he's
On
streaming
his channel
and like mentioned me. I don't know. We'll see. I don't keep up on the Twitch stuff. Anyway, it's still a work in progress. Like, I don't think any of this works and there's no usage, but you can build it from source, and there's instructions here, which is, it's pretty straightforward. there's a lot of stuff that we build the Linux kernel. We build a lot of stuff, but luckily we do all those in containers. So you really just need to have Docker installed and then go in TinyGo. I mean, we could have the whole thing build in Docker, but and I've had a couple of people try getting it to build from a fresh checkout. In fact, Tara, why don't you try cloning the project and getting it to build?
Okay. Like right this minute.
You do. I mean, you could. I mean, it would be nice if you could do it now, but in parallel. But if not,
Sure, why not?
we can do it later. I'll just kind of keep going here. But yeah, so it's going to build a bunch of stuff in containers, and then you can do a make build, and then you get a Wanix binary, and then you do a Wanix serve, and then you'll basically be able to do everything that I'm doing here.
Yeah, I'm not going to remember all that.
No. I mean, if you go to contributing, there's these instructions. If you just follow those instructions.
I have the Wanix. I have the Wanix repo already, and I was like, I'll just delete it because I don't know what state it's in.
Yeah.
But then it says this operation can't be completed because the item repo is in use. Excuse me?
Whoa. Maybe you have like a terminal open running a program inside it or something. I don't know.
I don't.
Well, dang. I don't think I can troubleshoot that with you. I mean, you could just clone it to a different location. Leave the old one.
Yeah. Okay.
But let's see. So that's kind of a big news. Is that we're sort of getting it ready for a quote unquote release, preview release, 03 preview. Also been cleaning out issues and stuff, and just cleaning it up. But man, a lot has happened. Let's see. I'm trying to think about that segmentation fault. Oh yeah, I was gonna. We could try and reproduce that thing, so I could kind of. So I believe it had to do with. Well, we were getting a segmentation fault because I think we were trying to mount something that already existed. We were trying to mount the Linux dev file system, and it didn't like that. And as soon as I commented that out, I don't know, it was something like this. It was like dev. It wasn't devfs. It was like dev tempfs or something. I don't even know what that is, and I'm trying to remember where that code came from. But, you know, I thought that was the idea. You know, /dev is a special directory that Linux manages. And so I thought that's, you know, this is setting up that directory. But it was, we were getting that segmentation fault. So as soon as we got rid of that line, it worked. And there was still a /dev. So I don't know. I guess maybe you don't need to set up /dev. I don't entirely know what's going on there, but got past that, and then I don't know. So many things. I've been just like heads down on this for the last week, so it's hard to remember. Even just 2 days ago. But what we can do is just say like, here's where it's at. So let's do that, and I can show some of the things. But let's see. I changed the prompt. It's a little arrow.
Nice.
And before everything was /Wanix, you'd start out in a Wanix directory because we were mounting the Wanix file system to /Wanix. Which is kind of weird because then in Wanix has its own root, but then you're in this shell. It's a Linux environment, and now Wanix isn't the root. So that's kind of confusing, and I didn't want you to have to kind of deal with that translation. It would be really nice if in the Linux environment, your Wanix root was the same as your Linux root. And so that's part of the renaming of some stuff recently and everything. But it also means that the root file system that we're using for this environment can be managed by Wanix, which means we can do all kinds of Wanix-y things, like binds and stuff like that, and it would apply to the Linux file system. Anyway, now the root file system looks like this. It's sort of merged. We've got a bin directory. It's a Linux thing. All our commands are in there. BusyBox is in there. /dev, standard Linux directory for devices. Lib, we can get rid of this at some point, but there's some files in there that are just kind of needed for BusyBox. OPFS is now a symlink. We'll look at that in a second. /proc is the Linux proc. So it feels like a Wanix-y thing, but it's actually Linux. And Linux kind of depends on it, so we can't get rid of it. There used to be a sys directory, but that's actually optional. So there's no sys directory. I don't really need that. It's just some it's kind of like the proc file system, but has other system things. I don't know. I don't really use them. Task, which is for managing Wanix tasks, which is what we used to call a process. And then web, which has all the stuff that's integrated with this web environment. Web workers. The VM is web specific, so it's under web right now. Service worker, there's OPFS, and then the DOM. So they all live in harmony. Oh, and the cap directory, that's capabilities, which is how we can kind of create new file systems and file services and stuff.
Also known as what, tasks?
Well, those are almost the two concepts in Wanix. A task is a thing that runs, but it's also a namespace. And then a capability is some file system. So let's see. OPFS is now a symlink. It behaves kind of weird. I think when you follow a symlink, the directory you're in is supposed to be the name of the symlink. But I didn't fully implement that, so it's almost like a redirect. It's fine. It's weird. If we say current working directory, it says /OPFS. So funny stuff. Symlinks are weird, but anyway, that kind of shows that we have symlinks working, because this is actually there's a lot of stuff that we could talk about, but this is an in-memory file system. what else? Anyway, so that's really the main thing is we're now booting a Linux VM. Or rather a VM that launches the Linux kernel. And then the Linux kernel is told the root file system is going to be not some disk image or even an initram fs or anything. Where it's going to get its root file system is over 9p and is served by Wanix. And so our root file system, 9p, you can say, what is there like a subdirectory or something that you want to use when you connect to this file server? And we're like, yeah, we want to use web VM. So that's the kind of initial VM that's created. File system. So what we've done is a convention of like, we can set up a root file system for this VM, and we'll put it under this VM resource. So now we can kind of set up this directory to be whatever we want for this VM's root file system. It's almost like a Docker container. We could like get some other file system and put it there, and then if we boot this VM, it'll become whatever that system is. Like if it's an Alpine system or an Ubuntu or whatever, like the file system in Linux defines the system, and we can sort of create that system from Wanix now. So we'll see how we can do that, but this is just kind of how it's being wired up. And so yeah, that's our what's giving us this shell. But then what the actual file system is, which is BusyBox and stuff, used to be part of our Linux build because it would produce an initram fs. But now that it's sort of part of Wanix and Wanix can set up that system, we have to kind of do a different path to set up this Linux system or file system that we're going to run. So there's a new kind of top level directory called shell, which its whole purpose is to produce this shell.tgz, which is basically a compressed tar of an initial file system that includes, all the stuff that we would want in here, mostly BusyBox, but then we can put other scripts in there, like our init script, right? What the Linux kernel is going to run once this file system is mounted. And then we can put other stuff in there, like we've made this bin directory, and basically anything in this bin directory will get copied into the bin directory for the shell. This is all built in Docker. And then it produces a shell tarball. So it's basically just a compressed file that has a little file system that has BusyBox and wexec and our preload thing and these libraries, some pre-made directories in a little compressed archive. Then we serve that. So when we're doing Wanix serve down here, we can serve some static files. And so the shell directory, like I've done in other places, has a Go source file, which now makes this directory a package with one variable, which is the directory and an embed. So what this does is this makes this directory a Go package. We could import shell and then we'd have a directory, shell.dir, and that would be a little file system, in-memory file system that would have our shell.tgz because we've embedded it in the binary. So for example, when we serve, we're like import shell, and then dir is a file system. So we'll just kind of mount it here under, we've got a couple of directories, v86 Linux shell, and then we serve that directory. So now we can access the shell.tgz over our web server. So then we have to load it into our environment somehow, which I guess is done. So our main sort of WASM entry point, the Wanix sort of like main module is here. And this is where we set up, what we used to call the Wanix kernel, and add some modules, which is pretty much just, saying what the initial file system is going to look like. And then we respond, we basically expose that file system as an API, and then whatever, that's how, I don't know, this is just such a weird system because it sort of just kind of, you use itself to set itself up. But the new thing that we have to do now is we have to bring in the shell, that tar file, and somehow put it into our file system. So this is kind of a short-term thing. And it's very ugly because we're doing a bunch of calling out to JavaScript. We can see we're actually doing a fetch, like a JavaScript fetch, asynchronous, download some URL, get the tarball, and then, once we download it, we put it into a buffer in Go, and then Go's standard library has a gzip reader. So that basically is like, give me some bytes or a reader or something with a read, and it will basically decompress it, uncompress it. So then we have a gz reader, which is now the decompress, basically the tar, the archive. And then we can put that into this tarfs because, a tar or a zip or whatever is basically like a little file system, right? It's just like a container of files. So tarfs turns that tar file into something that looks like a file system. And we can do all kinds of stuff once something's a file system. So once this is loaded, it sends it on this channel, and that's because this is happening asynchronously, however long it takes to download this and then load this, decompress, whatever. So eventually this is done. And then the rest of our code keeps going until here we sort of do a receive on that channel, which basically is going to say, we're going to wait until all of this stuff is done. And then when it is done, we're going to get the tar fs. Okay, so now we've got basically the contents of that tarball in a little in-memory file system. And we'll say it's read-only because we don't want to change those things. But on our file system, we do want to change them. Like we're going to run BusyBox. The way it sets itself up is it makes a bunch of symlinks. So we need a writable file system. If we just used the tar, we would, it's a read-only file system, so we couldn't actually do any of those writes. So what we do is we create an in-memory file system and then copy everything. And this is one of the first times I get to use this copy utility that I made. But it lets you basically do a copy from one file system to another, including maybe just the root. So here we're saying copy everything in the shell file system, the little tar file system, into this in-memory file system. So now we have a read-write version of the file system, basically of the contents of this tarball. And then we put it into the system as a hidden directory called shell, which means we can always kind of, these are sort of like system or built-in things. You're not going to see them on the directory, but they're there and you can use them. And then I guess what happens next happens on the page, on the index .html, because we do a bunch of stuff in here to boot up the VM, to set up the terminal, set up the VM, wire them together. And this is also where we set up that file system. So remember, the VM is going to try and use this fsys directory as its root. But where is that defined? We define it down here using bind. So the first thing we do is we take that shell, so basically a in-memory file system, read-write file system based on that tar file. We bind it to fsys. So now that's, if you were to go to fsys, you would see the contents of the tar file, and you could change, you could create files in there. But then we do a couple of other binds. We take the other sort of main root things of Wanix, cap, task, and web, and then we mount those in there as well. And so you basically get the combination of, this sort of like simple Linux system with BusyBox and whatever other scripts we have in there, and whatever else is needed for Linux. And then we add these other these other directories to it. And then the end result is, this boots a Linux VM. And we end up in a shell that has a root file system that is a combination of, the tarball that we made and these Wanix things. So anyway, if we wanted to, we could bind other stuff into this directory and it would show up in here. So it's sort of like this root file system is, because it's Wanix, it's now sort of like programmable. We can customize it through Wanix. We can bind other things in here or whatever. So that's really cool, and it's kind of a weird, like, technical, is a weird, challenging Linuxy thing to get all of that to come together. But the end result is now we sort of have this hybrid root of Linux and Wanix, and yeah, I'm just kind of happy how it's all coming together. So that was the big thing. And now that works, we can kind of just have fun. So other than like cleaning things up, another thing I checked is like, how big are the assets for this? Because the old versions of Wanix, they were huge. They were like 60 megabytes. So I had to have a loading screen. In total, this page is like 20 megabytes, which is a lot less. And that includes a bunch of uncompressed stuff. But in theory, we could kind of bundle all these things together and compress them. And so I did that, and to see how big it is, and it's 5.8 megabytes. So under 6 megabytes. And that gives us Wanix. It gives us this shell, based on BusyBox. It gives us the Linux kernel and the v86. emulator. And so that seems like a lot of stuff, like the Linux kernel. It seems like that's huge, but it's actually, like 1.5 megabytes. Then this emulator is 2 megabytes. Anyway, so we can do more than the old Wanix. We can run Linux programs, we're integrated with Linux. This emulator can run other operating systems. So we can do so much more now, but the actual like file size of everything is like a tenth of what it was before.
So that's pretty impressive.
That's exciting. So the shell module. Okay, so some things that I started today, I was like, let's have fun. And now we can kind of easily add scripts. So, a lot of what you can do is based on the file system. If we wanted to like make an iframe, we'd say like cat, web dom new iframe. It gives us, an iframe, a DOM resource 2. If we went to web DOM, we'd see 2 in there. That 2 directory is our iframe, but we don't see it because just like if you were to create it in JavaScript, you'd have to attach it to the body. So we can do that by saying append child 2 to the body's control file, and then we have this iframe, which we styled so that we can kind of make it a window. It's actually like draggable, even though it's buggy. But I think we saw this last time.
Yeah.
And then it's an iframe, so we could change its source to point to the root here, which is basically going to create another terminal. So if we do 2 adders, we're basically setting its source to /, so that's going to load it. And so now we have another little Wanix inside Wanix, little Wanix shell.
Wow.
The windowing stuff is like very rough. I was just like, how easy would it be? But it doesn't totally work. Like I can't even give it focus. So I can actually use this, but it's a good little demo at the moment. And then we could also get rid of it. We'd say remove. So now the whole point is like, the file system, you don't need a library. You don't need a command or anything to work with this now. You can kind of just like interactively work with it, similar to how you might do it in the dev console. And the point isn't necessarily that this is like a better way to do it than like doing it in the console. But I don't know, it actually kind of feels a little nicer. And the thing is in Plan 9, a lot of the things that you would do on the file system would just be wrapped in shell scripts anyway. So I actually made this DOM CTL, and we can use this instead to do what we just did. So we could see what kind of DOM elements that we can create by saying DOM CTL new, and it'll list things we can make. Okay, let's make an iframe. Okay, it made an iframe 3, just like before, only this is just a little bit nicer than doing, cat whatever. And then we could use this to refer to other resources like body, and then send commands that way. So we'd say body append child 3. Yeah. And we could say DOM CTL 3 remove. So now we have this little command line tool that is a little more familiar, a little more ergonomic than working with the file system. But it's all just doing file system stuff underneath. Like we could look at bin DOM CTL. Oops, not Vim, VI. And it's a little bash script. All it's doing is taking the first argument and saying, okay, if the first argument is new, and there isn't any more arguments, then we'll just list what's under new. And then if there is an argument after new, then we'll cat, new thing, and then that'll return an ID. And then if the first argument is not new, we'll assume it's an ID. So we get that ID. Shift is weird. It sort of like changes all your argument. It pulls the first argument off. So now $1 is actually the second argument. It's kind of a weird way to do it, but it actually is probably the most concise way, because then we get 1, assign it to ID, we do a shift, and then now our arguments are basically all the rest of the arguments, and we just put the rest of those arguments in an echo that we pipe into the control file for that ID. So does that make sense? Like we can, domctl body and then append child 3 is the same thing as echo append child number, So we're still using the file system as the API. We're just kind of wrapping it up in this little shell script. And I don't know, it's a little bit more convenient because now you can be in any directory and just use domctl, and you don't have to, figure out what path, is it relative or whatever.
Yeah, but they could do it either way.
Yeah, you could do it either way. But anyway, that's how Plan 9 works. Like Plan 9 has a bunch of commands to do a bunch of interesting things, but then you look at them and you're like, oh, it's just doing file system things. And so it's, maybe a layer of abstraction, kind of optional, kind of a convenience. But because it is all file system stuff, it's all stuff you can do in a shell script. It doesn't really require that we like create a Go program and da-da-da-da-da. Like this actually fits, the complexity and domain of a shell script really well, right? Like this feels like a really simple, elegant little program. And it's just because it's just translating arguments into some fairly conventional things. Like we could probably even make a general version of this that works for, any of the things that have this like clone dance where you do a cat new and then send messages to control. Like we could do the same thing for what else do we have? Like capabilities, for example. So that's neat. And it's weird that we haven't really even, in order to do that, we needed to have a shell that worked. And so now we have this Linux shell. And then we also needed a way, like where are we going to put those shell scripts? Now we have a place to put them. We can put them in the bin directory for the shell. So this is the source for it, shell bin. And then, so we can create other scripts under bin and, rebuild the shell and rebuild Wanix, and they'll end up in the bin here and be callable. So that's fun.
Yeah. Very cool.
Another thing that I just kind of added was, we talked about this last time too, when you have a shell, depending on what the shell is, it usually has a thing where you can like set up a shell script that runs every time you start the shell. Sometimes it's called profile, whatever, but it's basically like in your home directory, and it's a convention where it's like basically it's including that file when it starts up every time. And that gives you the
Mm-hmm.
opportunity to do stuff like set up your environment, so you could put in environment variables you want to have, maybe API keys or something. But also you could set up shortcuts. We were talking about how I used it for like Git stuff. Git is the only command I ever created aliases for. But I haven't set them up on this new machine. But it'd be stuff like I write git pull, rebase, origin, main so often that an alias of GPR is what I used to have. But anyway, you put those things in your profile or this little shell script that is included every time it loads. And so, I wanted to see, kind of set that up for Wanix. So in OPFS, which is our main sort of persistence mechanism in this environment, like everything else is ephemeral and dynamic, but OPFS is persisted, at least for this domain, on this computer. I created etc. It's a Linux convention or Unixy convention. The etc. directory is originally supposed to be like all other system files that aren't like library executable things, and it ended up kind of being where configuration lives. But also, some shell scripts and things sometimes in there, because I'm pretty sure Linux will often look at etc profile to load an initial shell script. But anyway, there's a file in here called profile disabled, and if we look at our init script, before it starts the shell and all this stuff with our custom, that's funny how the Unicode shows up as ... here. I wonder what happens if I save, if that is replaced with, if you look at this is a little, the arrow is a little Unicode thing.
Oh, yeah.
But when we open this file here, something doesn't support Unicode or something. Anyway, there's a little bash script thing. If this file exists, then we'll source it. Dot is basically source, which is like include. It's like, as if you were to take the contents of this file and enter them in the keyboard. So source that profile if it exists. So now that's kind of cool, because I don't have a move. We have to implement move on this. Like this is going to say function not implemented. Okay, that's a to-do. That's an issue. But in the meantime, we can just copy it. Copy to profile. And I'll actually leave the disabled one there just so I can just delete profile when I want to disable it again. But so now there's a profile. And it looks like what we're doing in it is creating an iframe, appending it to the body, and setting it to... So basically what I showed you before, like it's just setting up an iframe and setting it to /. And so because this is persisted in OPFS, if we reload now, it runs that thing. And I didn't realize it, but you can kind of see it's a nested thing. It only goes 2 levels, but if the window that we're opening here is also running that auto script, that profile, it's going to create its own iframe within it. So you can see that I don't know why it didn't keep going, but the reason why this width is extra thick is because it created a window within that window, because it's the same environment out here. Crazy. Does that make sense? Is this You're muted, by the way.
Sorry, I was just blowing my nose earlier, so figured you didn't want to record that. Yeah, kind of. It's definitely like outside my, typical sort of the way I use the terminal and stuff.
Right.
So
if you're, yeah, that's why I'm like, this is, weird infrastructure. It's something that's familiar to people that are more familiar with Linux stuff, but
yeah.
The end result though is like this kind of customization. It's like, oh, now we have a way to set up a particular environment, right? It's kind of an auto run script. It could, yeah. Anyway,
yeah, it seems super convenient.
It's one of those things where it's like, okay, then you could set it up to, check your GitHub repository and pull in scripts from there. And then you have this like global place that will always define. There's no login yet. There's no users in Wanix, but eventually there will be. And so we can use that to, access, login with GitHub, and then get access to a repository there. It could be mounted like our old version of Wanix. We could work with that repository as a file system. Oh, if we want to get rid of this, we can use our DOM-CTL thing. We'd say to remove. Cool. So, fun stuff. Like the system is coming together enough that, we can kind of start defining more interesting like user space stuff, I guess is how I would describe it. Like little utilities and stuff. What else? Okay, that's pretty much everything that I did since Monday, which feels like a lot. Did you get a checkout working?
Well, it was kind of hard to do that and pay attention to you.
I know. Yeah.
I did just clone it, but then I kind of paused.
Okay. But yeah, that's kind of usually we go over stuff until noon, but we're a little early. Some things that we could work on today, though, instead of, like previous streams, it's like, oh, let's work on this hard problem that I'm blocked on that I have to do a lot of debugging. We're kind of back to like, oh, we can write little scripts and do little fun things. So I was thinking we could kind of do a little DOM-CTL script for the capability thing. It'll probably be exactly the same. Thought it'd be cool to create a command for doing Wanix file system binding stuff so that you can more easily kind of assemble and customize the file system, the namespace. There are, when we started, we had this whole other way of using Wanix where instead of Wanix serve, you could say Wanix mount, and you'd get a version of the file system, but on your host system via Fuse. It'd be interesting to see if that still works. Yeah, we haven't looked at that in a while. But yeah, I mean, all of this stuff is kind of like optional things. Like they're not critical things for the release. We still have I got to make issues and finish the README and release notes and stuff. But I think I was saying at the beginning of this, or before we went live, how this is day 17. I feel weird ending not on a round number. So, we can go to 20, and then 20 can be like the release, and we'll do like a big prepared demo or something.
Sounds good.
But in the meantime, I mean, break's coming up. We'll take a break and then we can come back and work on some fun stuff. We're back to like we could probably knock all of these things out today. But some other things that I've been thinking about that maybe we could do if there's time left is, basically continuing on for what I want to add to the 0.3 release is just saying like, the 0.3 preview release is just saying like, here's a kind of an alpha version that does mostly, it captures the essence of what I want to do, but it doesn't do everything that I want to do. So I want to have time to do those things and refine and get feedback. And then we can do a real 0.3 release that's actually like has a compelling story to it,
Yeah.
But some stuff that would be kind of cool, this, right now we run Wanix serve and certain files are served over the server. Like you saw, we like serve the shell tarball, we serve the Linux kernel, we serve the v86 files. Those are all sort of downloaded from this HTTP server. And so if you were to close this server and, reload this page, obviously it wouldn't load. But in theory, it could load. It did here because it's you can cache those files. And we have a service worker, so we can kind of decide whether we fetch things from the server or not. This doesn't work though, does it? I don't know what exactly happened here. Like, this is kind of magic. I'm not sure what's going on here. It's like we reload and it's like, oh, it can't be reached. Wait a minute. Let me give you your exact state from before. And it still works. Like, I have no idea what has happened here or why this works. But in theory though, but that kind of gets at where I'm heading is, in theory, you could make it so that it downloads these files once and then stores them in, a cache or whatever, some cache storage, whatever. And then the service worker can be like, oh, I'll get it from the cache instead of getting it from the server. If you do that for every file, then you don't need the server to run, right? You can just run the server once and then you get this page. Then it sort of installs itself into this browser, because then if I close the server, I'll still be able to go to this domain and everything will be there. I think I mentioned that early on in one of the early streams, that's kind of where I wanted to go, but that's kind of crazy, because it's sort of, I don't know, it's a weird way to, and then eventually I want to make it so that you can, you'd say like Wanix serve and then some domain or some name like foo. And what it would do is it would magically create a foo.local domain. And now you have a named environment that just kind of lives in your browser. Once you've loaded it once, you can always go back to foo.local and it'll have whatever is the state of your OPFS. And that's kind of a weird, cool thing. It's like, I don't know. You only use the Wanix command line tool to bootstrap a Wanix environment, and then it just lives in this. It only works in this browser because it's, local, stored, cached in this browser. But if you were to just run the server again, you could open it up anywhere else. Anyway, that idea is very compelling to me for some reason. So that's something we could get to at some point. Also, the fact that it it would be over HTTPS, which is kind of crazy, because doing like local stuff with HTTPS is like a hassle. But then to make a web app that still works over HTTPS, even though there's no server, that's wild. But that is the whole point of like the progressive web app model, is they're trying to make web apps be more, native like experiences. And part of that is like instantly booting up and all this stuff. So that's where all this like caching and service worker stuff came from, was this direction that the web is taking with this like progressive web app stuff. So we're taking advantage of all these technologies to... Progressive web apps gets into a bunch of other stuff, but at the very least, it's like the idea is you can load the application once, it can cache itself, and then you can use it offline. And I don't know, that's pretty cool.
Yeah, I mean, you never know when you need the option.
So the idea is you could like not just create Wanix environments that then live at some name, but you can create whole little apps, because this is an app development environment ultimately. Like you'll have VS Code, whatever. And so what are you going to use that environment for? And then like, could you publish that and then make, an app that is, you could build something in Wanix and then take that thing that you built and then publish that, standalone. Or you could just take the whole Wanix environment and publish that, and just have the auto start script like start your application and kind of hide this terminal so that users don't actually see it, but it's there. And advanced users could go in there and maybe get to this terminal, and maybe you have cool advanced functionality of your app only accessible through the terminal. Anyway, just, crazy ideas of what's possible in the future with all this stuff. I think it's exciting.
Yeah.
I think we should take a break a couple minutes early, and then
Well,
maybe when we come back,
12:03.
we can talk through the build from source and just see if you have any problems.
Okay.
Yeah, so 5 minutes, so 12:03
and a half. Yeah.
Okay. BRB. Yo,
Hi.
why don't we? I'll do a checkout with you.
Ode along. I like it. Okay. I did clone it.
Yeah, and then we'll make a new got a temp directory here. Git clone. Oh man, it's already in here. Get rid of that. Wait, hopefully it's not anything important. Maybe it is. I don't know. Move Wanix. Wanix old. Okay. Now clone. All right. So what were the instructions?
Can you, by the way, make the text bigger in your terminal?
Oh yeah, it's super tiny.
I think my internet, I don't know. Streaming is still like, it should be higher quality. I have goddamn fiber internet.
What provider?
Sonic.
Ah.
The gold standard, as far as I know.
Mm-hmm. I'm on Monkey Brains, which is wireless. It's actually on the roof of the apartment building, pointing to San Francisco and beaming.
What you get when you can't get Sonic?
Yeah. I think I can get Google Fiber here now. Okay, make sure you have these tools installed. I will make sure. Docker version. Okay, that works. Go. 123. Okay, go version. 123. Okay, got it. Tiny go. Version 3.5 or greater. 3.6. Okay.
Well, I don't have Tiny Go.
Brew install Tiny Go.
Also, did it specify a version for Docker?
No, I don't care what version.
Okay. The cursor's just blinking. It's gonna do something. Oh yeah, I guess it's doing something. Okay.
Brew is very slow.
Yeah.
It's kind of annoying actually. They wrote it in Ruby. Ruby is like so slow.
No available formula with the name TinyGo. Is there?
So this feels like something I could put as a note in here, but this does link to, well, okay, what do we do? I guess Mac. It's not in the main brew. You have to brew tap tinygo.org.
Okay.
Maybe I'll put this in, well, this is Mac specific, so I don't know that we need to put that in here.
Is that not for silicon?
It should be. Why? Does it say?
Well, if you go back to that page, it said something alternative for M1, M2, or
alternative version. Oh.
But I don't know if that means the other one is not for.
Okay, yeah. No, I think what it means is you can use this. If you're on a Mac, you can use Homebrew. Alternatively, you can do this or this.
Okay. All right. Well, it's in. Well, let me double check. TinyGo version. Oh, it still says. Okay. I'm just looking through. It seemed like it installed, but it says command not found when I tried to do TinyGo version.
Huh. Open up a new terminal or shell and then try it there.
Nope.
Hmm.
Command not found.
You must not have some
Let me try running brew
directory in your path.
I'll try running brew tap again and see what it says. Oh, it did nothing, so I guess that means it's already.
Yeah.
Do you want me to share my terminal? Oh wait, I can't. How could I even do that? I guess in Discord.
Yeah, you can share your screen.
That seems like a. Do you want me to?
If it helps. Yeah, sure.
Well, it might help you.
Try. Yeah, let's do it. And I think there's a way to pop it out. Your screen is going to be streamed. You're okay with that?
I mean, it's just my terminal.
Okay.
There's nothing really.
TinyGo version command not found. Brew tap, TinyGo tools. Okay, and then do brew install TinyGo.
Oh wait, I didn't know I needed to do that.
Two commands.
Yeah. Well, what the heck does tap do?
Okay, brew. All the names of things that you can install with brew are in a repository, the homebrew repository. And it like fetches that repository every day. So if you want like the latest stuff. Anyway, if you don't, there's a lot of stuff in there and you'd have to like submit a PR to add something. Ugh, super annoying. But you could also just create your own repository. And so tap basically tells it to look for a GitHub repository with this name that is a repository for brew. And then that's added to sources that you can install from. So then you say brew install TinyGo, and then it'll look there and be like, oh, that's where TinyGo is. So it's a way of adding another repository, which is easier to control. Like that's what we would do. I think I have a program. Well, what is it? I don't remember what it's called. Tap or brew. Surely I have. I was pretty sure I made a. I just forget what it's called. Homebrew taps.
I'm gonna put a cough drop in. Let me know if you can hear it, but otherwise I feel like I'm gonna cough all over the place.
Okay. Anyway, so this is my repository. And so if you were to do brew tap program homebrew taps, then you'd be able to say brew install any of these things. Brew install Wanix.
Oh, okay.
It'll be like the old version, but this is set up. And so when we do a 0.3 release or something, or even the preview release, I could add it here. And then people could do brew tap program homebrew taps, and then brew install Wanix. Anyway, that's why it's a two-step process.
Okay. Makes sense. Anyways, I'm ready to continue.
TinyGo version.
Boom, there it is.
Looks good. So then what was the next step? Docker is used. Both are used. Run make all. That'll be fun. Actually, hold on. Let me time it. I want to
Oh, it's really funny to see how behind my stream is, because like I just a second ago just watched myself type tiny go version of your stream.
Yeah. So if we're in the Wanix directory, run make all. Wait, is
Wait,
that not
what?
the right? What?
What? Oh. Am I going crazy?
Let's say
Oh,
clone
okay.
Wanix. It cloned it.
Well, I thought I
You
meant to
made a
put it.
directory, and then but that puts it into a directory called Wanix.
Yeah. But I already had a directory called Wanix.
Well, that's weird. There's a couple of them. Is this the one that you had before, though?
Well, how can I check if it's like up to date? Get status, I guess. No.
Right,
Get
up
just
to date
pull.
with main. Yeah.
Get pull origin main. Is it
Yeah.
/main?
No, I don't know why. I always thought it was /main, and I don't know why. I mean, I guess it kind of makes sense, but yeah, it's just space. Anyway, so yeah, in here you could write make all, and we'll see what happens. Oh no, Docker's not running. I guess you did Docker version and it came up. So you have Docker installed. Okay, but if you did, okay, but it says it's not running. You probably installed it with Docker for desktop, so you probably need to like run Docker desktop or something like the app.
Okie dokie. Okay. I just opened the app. Is that good enough?
Yeah, and then in theory it should live in your menu bar and you could close the thing and yeah, okay. Do Docker PS. Okay, yeah, you're good to go.
Nice.
So make all. All right. I'm running a timer to see how long this takes on someone's compute. What is this?
M1.
An M1.
16 gigs memory.
So it's interesting. Okay, I think we can kind of see what it's doing based on the Docker build command. So it's building. Right now, it's trying to build the Linux kernel. Okay, and for most of these containers, it has to install a bunch of dependencies and stuff. So that's what it's doing here. It's setting up everything needed to build the Linux kernel.
Cool. 6 out of 10.
Yeah, I guess those are like phases. 6 out of 10. Oh, maybe that's 10 for that container. I think those are steps. Okay, yeah. No, I don't know. I don't know what's going on.
Well, if you don't, I definitely don't.
It's funny that it's like not doing anything interesting right now. It's just like trying to download these files. So it's actually your internet that is the bottleneck here. Maybe because you're watching my stream and sharing your screen and stuff. How fast is your internet?
I mean, what is that website?
It's a speed test site.
Yeah. I mean, it might be a little messed up right now. I feel like it's not. It's usually better than this. I don't know.
Open up a new tab. I'm just kind of curious, or a new session, so that, yeah. And then ping. Let's see. I'm waiting. I don't know. Wait. Maybe your screen froze. I don't think it liked the fact that you just changed everything on the screen by switching tabs or something, but.
Well, I did open a new tab and I typed ping.
Ping 8.8.8.8. Is this
Not.
what?
Can you not see it?
No, I can't. Try re-sharing your screen or your window. Okay. Just looking to see at the kind of health of your, it's didn't know if you're, I actually, when it's rainy here, because of it being wireless, I get some drop packets or whatever, but this looks pretty stable. Also, it could just be like the Debian servers are slow today, maybe. So you're really at the whim of the fucking internet with this stuff.
Well, oh.
Anyway, you could Control C out of this if you wanted.
Some sort of error.
You also closed the window. I don't know if you, so it ended the share.
Oh, maybe it was only, sharing that tab.
Yeah, that's weird. If it could do that. Okay. So there's an error. What is this? Failed to fetch. Oh, that's a boring error. Hash sum mismatch. That's dumb fucking error. That's just apt-get not working.
So
try it again. Yeah. Kind of makes me want to install each of the dependencies as separate run steps, because it would cache the old ones. So if they were already installed, it would skip it. But
how many steps would that be?
You can see in the where it outputs the Docker file at the top there. It's like work dir build and then run. And then the lines after that are basically all the dependencies. So those would just be on separate lines and they'd be installed separately. So if one of them failed, it wouldn't have to download all of them again. But
although I think I'd rather have to sit here and wait than have to type in a bunch of stuff separately.
Yeah, you wouldn't type it. I'm just saying, like, if I set up the Docker file differently, then it will cache the steps. Like, because they're all under one run, this is one step, and it has to complete in order for it to cache.
So it's your fault, is what you're saying.
No, it's their fault for not having a reliable package repository. It should just install these things, man. Debian, install the packages. What's wrong? It's their fault. But yeah, maybe because they're not always as reliable that it would be worth splitting them up. I don't know. Okay, again.
Looks like the same.
Damn.
Errors. Yeah, is there anything to do for this except for to just try again?
Let's see. It says maybe run apt-get update. Maybe. I mean, we're running apt-get update before every time, so it should be the latest And so, no, you don't do it because that's in the container. Let's see, or try with fix missing. I don't know what that does. I mean, we could try a different version of Debian, and then maybe
it wouldn't be because I'm using a VM, would it?
No.
Or not a VPN, I mean.
I mean, it could. In theory, a VPN
off.
provider could try and cache some stuff. VPN providers, I imagine, are trying to save money on bandwidth. And so if they cache certain sites that are accessed a lot, like Debian packages or something, then maybe they'd save money. So it's possible that that your VPN is causing the problem, but you would think.
Well, I just turned it off just in case.
I mean, I don't know what is happening right now. It's sort of sitting at something that looks similar to the error from before. I don't know if it's going to error or keep going or what. It's just sitting there. No, keep going. And actually, I don't know if it's. Yeah, it should.
Oh, I can actually see how far behind it is because of the building value. Mine's no, it's done.
Oof. Oh, it's a different file though. Failed to fetch. Hash some mismatch.
Is it?
Come on, Debian. Bad header. Yep. Well.
Well, do we just give up for now?
Maybe. Yeah. First stream is pretty boring.
Yeah.
You could try it again later and maybe it'll work because maybe it's an upstream thing, like maybe they're having problems or something.
Okay.
And then like if it's still a problem, we can try some different things. But hopefully it's not. I don't know. It's like the stupidest place for it to fail.
A bit.
Okay, well, maybe if people watching have a better experience, let me know, or if run into any other errors. So, all right, we'll say we did that. Pretend we did it. Let's see, we could make a capctl command because that would be fun. It's literally this, but with different capctl. Boop. But instead of whatever, it's cap. So in theory, we could create a generic like our resource CTL or fsctl or some like generic command that these wrap. But for now, we'll just make separate ones. But I think I need to chmod this bin. Yeah, chmod execute bit on capctl. And then this is separate from the main thing, so we do make shell. And then we can make Wanix and run Wanix serve. And then we should have a new command.
Boom, that was like 2 minutes.
Hold on. I forgot. I need to get rid of this thing in OPFS. RM profile. Okay. So it won't create that weird iframe every time. Boom, 2 minutes. What?
I don't know. It seemed like you were done.
Yeah. We made a new command in like 2 minutes. Yeah. So it's capctl, which I guess it does nothing if it has no arguments. Capctl new. Okay. And loopback is special. WebSocket's weird. Pickerfs is really the only interesting, fun thing. Obviously, we can have all kinds of capabilities in here, but right now there's just these. So if we wanted to do a pickerfs, we could say new pickerfs, and I was thinking it would be cool if the new command had more arguments, then that would be the equivalent of running capctl command on. Basically, it would take those arguments and then do this automatically. So I could say capctl1 mount, which will trigger the pop-up to pick a directory. Linux fs2, sure. So I guess if it was capctl new picker fs mount is kind of the proposal of like, if there's stuff after that, then it will run it as a command on it afterwards. So then that way we can do this in one command, which would be cool.
Yeah.
Cap1 cd mount. Is this? Yeah, Linux fs. The directory I picked was a Linux file system, so that's why it looks like that. Well, I was going to try something. If I delete... Actually, I forget which one it is. Is it... Oh, there should be a name or something. I don't know why there isn't name here. Because I forget which one of these I picked. If I create a file here, foo. Oh, it's that one. Okay. So foo. Anyway, just kind of a fun thing. We can delete files on my actual hard drive when you mount them like this.
Doesn't sound fun to me. It sounds scary.
Well, luckily, remove doesn't work, so. But it would only be in directories that you give it access to. But and then the browser is sort of responsible for making sure it's only the only files that you gave it access to. Anyway, so let's see. I don't know if this is... That must be a picker fs specific thing, because I'm pretty sure remove works in like OPFS. I've been deleting stuff like crazy. Let's delete that link. Gone. So I guess that's an issue. RM on pickerfs doesn't work. Cool. Well, I mean, I don't know. We could I actually didn't write this. I just was like, Claude, write this for me. Let's see if we can get, let's see. If there are, if arg1 is new and there is an arg2 and there is an arg2 and there are more arguments, use the remaining arguments. I guess this is called vibe coding.
I like it.
Use the remaining arguments to echo into the control file. In theory, what I kind of like about, I don't know, AI stuff is that if it has the right context, you can kind of speak in, you know, the language of your system.
Mm-hmm.
Did it do anything? I feel like nothing happened. Follow-up instructions. Make the edits? I don't know. What's wrong with you? Is it because it's only selected on that? Like, I don't know what's going on here. And I can't select my text to copy and paste it in another context. How do we? X. Let's get out of here and just say, what is it? I forget. The L to chat, KE to generate. Which is weird because they kind of feel like the same thing. I don't exactly know what the difference is. Like one's focused on generating code, but you can chat to generate code as well. Okay, it gave us a little snippet of code that maybe we can, it looks like it might be right. So argument 1 is new, and if there's an argument 2, then it's going to do this. And then if there's more than 2 arguments, it pulls the first 2 off and takes the rest and pipes them into, this will not work. We have to do what we did here, which is say, we want the output of this. ID equals okay, if there are more, then we'll do that. And if you don't pass more arguments, then we'll just echo the ID. But maybe it's worth echoing the ID regardless, so that you know, because you don't know where the thing will be. Okay. Maybe it will. Maybe it will work. Capctl. So if we did pick RFS and then mount, it should create one and then call mount. So it should like allocate it and then do the mount, which will cause the pop-up to show. No? Can't create because it doesn't exist. Maybe because we have kind of like a race condition or something. Oh, it's trying to create cap new. That's not correct. Here we go. I wonder if, I don't know, if we added like an ls command that would list them or something.
Mm.
Yeah, because otherwise you got to go to like cap directory and do ls, but all right. Capctl new picker fs mount. Ooh, let's do a different directory. How about this bin directory? All right, I don't know. We don't know where it is, but we know it's one. Cap one mount. Those are the files in bin. So anyway, that's I don't know. We could do capctl ls or something like capctl ls. I don't know what would that do. It'd be like, because in theory, maybe it could be like grep. Is there a pattern for number? What is it?
For number? What do you mean?
Do you remember regular expressions?
I mean, every time I use them, I have to relearn them, so no.
Yeah. Grep a number.
No, like D.
Oh, I guess it's like a class. I thought there was a shorthand for, yeah, like a D or something like that.
Yeah.
But whatever. We'll try this. I don't know what the O option ensures that only the matching parts are outputted. What a weird. I mean, let's see. Let's just try this. If we created another one, capctl new picker fs mount, and we pick some other directory. WASI. Okay, yep, 2. So then, okay. I mean, listing numbers is kind of pointless.
I think it's pretty cool.
I mean, if they had names or something, then it could like show their name or their type or something like that. Like they could show their type. Cat type picker fs. This would be like 1 parens picker fs or something. And if there was a name, it could show name. Anyway, that's actually how PS works, which are at least on normal computers when you do PS, it's actually a program or whatever. But in Plan 9 and probably old versions of Unix, PS could just be a shell script that would essentially do the same thing, but looking at /proc. And it would go through each of the ones and then could get their information from the files in it and then just print it out in a convenient way. But anyway, I don't know. That's something maybe for the future, some kind of ls to list them. I think for now we can just say like, yeah, just go to the directory for the thing and you know what the number is. So I mean, these are just like, I don't know, conveniences, just kind of fun experiments exploring. So
yeah.
I'm happy with this. So yeah, there's capctl. Again, maybe we should combine these so that you could do that with DOM, but maybe it doesn't make as much sense. Anyway, these are so short and simple that who cares? Oh, bind is fun. We haven't really played with bind in here. Let's see. What's something that I would... OPFS, CD, OPFS. Let's say, you know, we have this etc directory, and let's say we wanted to put it, oh, do we have an etc in here? No, we don't. Let's say we wanted to, for some reason, make that etc directory live at the root here. That could be a good use of bind. We don't have a command to do it yet. We'd have to do it through the file system. So it'd be like, let's see, how would this work? We want web opfs etc, and we want to bind it at etc, and we will task 1 is sort of the root task that we're effectively working under. CTL. Let's see. It didn't complain. It also didn't give us anything new here. So we also didn't get an error. So I don't know what's... Oh, this is, I guess, technically a different namespace. We might have to do, instead of putting it at etc, we'd have to put it at web vm1 fsys. That's actually the namespace that we're working under. Etc, there it is. So we just kind of like created this binding from one place to another. Files that exist here are also accessible here. It's like kind of like a hard link. Symlinks are symbolic where you see them. A hard link is like you can't even tell this exists in multiple places, basically. But this is the mechanism that we use to build up file systems. It's how this root file system was made and everything. So the idea is to turn this into a command that maybe takes this into consideration, so that we could just say bind web opfs to etc, and it will know, we'll prefix it with that so that it shows up in our environment. Like that's seems like a good, I don't know where the best place to do that in this system yet, but we could do it in a bind command. You know, the translation of, you're talking about paths, but really behind the scenes, all your paths are relative to the current namespace that you're in. How would that work? Well, let's make the command bind. Probably want to chmod it. So this is a really easy one to do, but this has a lot of assumptions. One is it's assuming that our task that we're operating in is 1. Maybe that's not the case. For now, it's certain things are hard coded, so it boots up. It's always that. But if you want bind to work in other namespaces, it can't be hard coded to that. I think you can do task self. No. Oh, that's another thing. The task file system is broken here, but for some reason it works over here. So like task self would give us 1, and so this could be kind of something like cat task self, and then that would give us the ID for this task. And this would be the first argument. And this part would be the second argument. But now how do we know where this is? It's like we need a web VM self or something. I mean, we could put this in an environment variable. Let's see, how else could we? I mean, in theory, this should be relative to whatever my namespace is. Like, I shouldn't actually have to put that in. It should know.
But does it know?
I don't know. Let's go look at the code for task CTL. Web. No. Task. CTL. We could do bind. Let's see. R bind. So this is a process specific bind. So it's actually for this namespace. What namespace is it? When we make it's a new namespace. What does that mean? Oh, I guess it's weird because this is a slightly different namespace. This is effectively the root namespace. And then, okay, let me think about this. The VM is being set up kind of manually on I guess the thing is that how do I make them the same? Maybe I in theory, we should be able to do something like when we set up this file system that's used in our shell, we should be able to say something like bind the root of this namespace to that file system. But the problem is we also need to have this shell. So there's like two ways to go about this. It's like we're trying to make this file system. It has the Linux shell file system, and then we add in our stuff like cap, task, web. We bind these things at our root to the root of this file system, which is what we see in the shell. But this shell should represent like this root namespace. So we should be saying our root should now be accessible at file system. I'm going to try something because in theory, you should be able to do this. And what this does is, because both of these are directories, they're supposed to become a union. So whatever contents are in this root directory, which includes cap, task, and web, I don't think there's anything else in the root at that point. By taking that sort of parent directory, the root, and mounting it there, that should put these files in there combined with whatever's in here. That's how it should work. I don't know if that does work, but we can try it, and if that works, that will mean something spam. Let's rebuild.
You always catch that right away.
Yeah, I've got like a wide screen so I can see everything all at once.
The same spam too.
Okay, it's possible because we're messing with the root. If it messes up, which I think it did, like we don't get a prompt because the shell virtual machine didn't boot. So that's why I'm hesitant to do some of these experiments with the root, because it's like it means we can still do stuff over here,
but it cripples you.
But yeah, it looks like somehow something wasn't right. Like maybe it can't find bin init because for whatever reason it can't get to these ones, even though it should. So something's broken. This should work. For whatever reason, it doesn't right now, which is kind of a bummer.
Yeah.
Because that would simplify this, because it would just mean... Anyway, it's almost one. For now, maybe we can just hard code it, and then I'll add it back. We'll just see if this works. So it's like web VM1. And right now you can only have one VM and da-da-da. So this is already kind of like, it's already hard coded. So it doesn't matter if we hard code this. All right, let's check this real quick. And then if it works, we'll be happy and we can finish on a high note. And if it doesn't work, then we'll finish on a slightly less high note.
For this sad rainy day. Is it raining over there? It's raining here.
Yeah, my watch says it's raining. All my blinds are down, so who knows?
Yeah, I figured. Do you keep them all down all day?
More often than I thought I would living here, but one of them has an automatic blinds thing, and I open that one sometimes because I can just go up and push a button. But the automatic IoT thing or whatever for it was like really expensive for what it is, but whatever. So it's like, I don't know if I want to get this for all of them.
Yeah.
Anyway,
Yeah, I can
let's try this really quick.
imagine that'd be tedious.
Let's try this real quick.
Roll.
What are we doing? We want to do like OPFS at C. I don't know if it'll resolve symlinks, so maybe I won't do the symlink version. We'll do web OPFS at C and then at C. Fuck. Oh, right. Because task doesn't work, so it can't get task self. One more. We can do it. We'll just hard code this and rebuild, and it'll work.
All right. So is that ending on a high note or like a medium note?
I mean, we're gonna end on a high note. Watch this.
All right.
Web OPFS Etsy. Boom. Etsy. Look at that. Cool. We made a bind.
Nice.
You take one path and then put it somewhere else. And it's only for your namespace. Very much like in Linux, Unix world, the file system is monolithic. If you make changes to the file system in one process, it affects all the others. In Plan 9 and Wanix, it really only affects this process and any other process that's sharing this namespace. And that opens up a lot of cool possibilities. I guess also we need an unbind. We'll do unbind later. Or I'll do one after the stream. Unbind. Okay. Good stream. I think that was fun. Saw some fun stuff.
Yeah. The little nuggets, I'm sure, are nice for viewers. A little easy to follow.
And yeah, well, I guess, let's see, 17, 18, 19, 20. So there's 3 more. The last one will be...
Did you really have to?
Yeah. What?
Have to count out.
Well, I didn't know what we're on. Oh, we're on 17.
Mm-hmm.
18, 19. Yeah, I count out. It's like a verification thing. You know, it's like, oh yeah, my brain can do the thing, but let me make sure. So if the last one is like some kind of big demo, then we have 2 more streams, which would be basically next week, Monday and Wednesday. And they'll probably be like this one, where we can play around with it and add some little things, show off anything that I've done, you know. But yeah, these last couple streams should be fun.
Oh, that sounds good to me.
Okay. End of stream. See everybody.
Bye, everyone.
Next week.